Okay, here we go. It's late. I'm tired, but we are going to finish. I forgot last time to update our code. We are in part 10. Let's have a look at what we've got. We've got a canvas. We're loading the screen. We've got an event listening to keys on the keyboard. We're prompting our game loop. We've got our variable set up here. We've just added a size and a tail array. We're running our game here. We've explained all of that stuff. We've got an apple that we can eat and it gives us a score and it randomly repositions itself. And we just added this bit here, which we said was more complicated than the rest easily. And what we happen to do is we are pushing our current position onto our array. Now let's just have a look at what that looks like. So inside our array, we've kind of got these objects, and these objects are kind of split into, we've got an X position and a Y position on here. So literally on one side of this, we can imagine there's an X, and on the other side, we can imagine there's a Y. Now we've actually called them TX, and we've called them TY for the tail sections. But at the start, they are equal to X and Y. And then what I do is I kind of take that first one and we kind of push it over onto the second one. So that first one becomes the second one, and the second one becomes the third one. And at the very start of the code, when these kind of get all pushed down, they all end up with the same value as the head. So they all end up with the X and the Y, the initial X and Y. And then what should happen is, as we move around on the screen, we should then redraw them, and the X position should update in the first block, and then it should have a legacy that kind of like shifts back through the array. That sounds complicated. I don't think I explained that very well, but we are finishing because it's late and I need to go to bed. So let's see how we can do that, right? We're going to go through. So where we're drawing at the moment, our single block, we're actually going to go through our tail loop. So we're going to use a loop to do that. We're going to use a for loop because we should know the size of our list, okay? And we do know the size of our list. We know that our list is, let's have a little look, it is length long. So what we can do is we can set up a for loop in JavaScript, and what that means is we initialize ourselves a variable I, which is going to start at 0. So we've got to put var at the start because we're making a new variable, and we're calling it 0. I don't actually think I need the var. I think I could probably cut that out, but irrelevant. We're going to go. We're going to use I as our counter variable, and it's going to keep incrementing until it reaches the length of our tail, and then it'll stop. And the reason we're going to do that is because we now don't just want to draw a single instance of a red block. We want to draw a red block for all of the parts of the snake. So how are we going to do that? Well, instead of using X, which is kind of like the global X position, what we're going to do is we're going to access our tail array, and we're going to access that using our I counter. So it's going to go from the first, second, third, fourth. It's going to go down our chunks. It's going to go down our sections like this. And when it does that, we're going to access the TX to start with. The TX, the tail's X position from there. Then we're going to multiply it by 20 because obviously we want to make sure that this thing is moving in blocks of 20. We're then going to do the same thing. We're going to take our tail, we're going to look at the ith position of our tail, and we're going to find our tail's Y position. We're then going to multiply that by 20, and that's going to appear on the screen. Now, that should make sense. That should work. Remember, you've got to, I've even put a prompt here to remind myself, you've started a loop, you've got a brace, you've got to remember to close the braces, even if you've indented in JavaScript. We don't actually need the semicolon. I could get rid of that because there's only one action being done within that loop, but that's kind of all irrelevant. Let's zoom out and see the whole code. That is everything. So it's 67 lines long. Let's save it. Let's see if it actually does what I wanted it to do. So we have F5, we're in part 10, and we've got ourselves a snake. Now it's not perfect, it's got issues. So for example, it concertinas up on itself when it touches the walls, and you can run all over yourself. There's no collision detection with your own body at all. But it is a snake game, and it does eat snakes, and it does eat apples, and the apples do randomly appear. And yeah, you've made yourself a little video game. Now, what could we do? So the challenge, I guess, is to do those first two things that are missing. So first of all, can you get it to check whether or not the head has hit the tail sections? Well, if we look at our code, we're already moving through the tail sections. We already know the X and the Y position of the tail. So there's the X position. Now, if that happens to be the same as the X position of the head, then the head's hit one of the tail sections. So we could just include that within that for loop with an if statement, and you'd know you'd collided with yourself. I think that's probably enough. Have a play, have a try, change the colour of the snake, change the size of the snake, make it so when it eats an apple, the size gets bigger. But play and have fun. Cheers.